Okay, this video is a video talking about the transformations and some parent functions, and this is a review for our test. So if we look at this first section, this is simply just reviewing what the parent functions are and then what the transformations are. We're not graphing any of them. So if we look at this first one, and I didn't write this in the directions, but it should say equation, just like we've been practicing. The parent function equation would be f of x equals x squared. The transformation, well, because this number 7 was outside of the function, then it moves it up and down, and it's going to move it the direction you think, so it's up 7. Over here on number 2, the function is the radical, so it's f of x equals the square root of x. The transformation, well, with this negative in front, that is a reflection. Okay. If it helps, just as a reminder, let's put our parent functions on here. We have the linear one, so f of x equals x. We have the quadratic one, f of x equals x squared. Cubic, where it equals x cubed. Absolute value, which is the absolute value of x. And the square root, or the radical. Those are the parent functions that you need to know. All right, so let's continue on. So if you're looking at number 3, the one that closely matches that would be the absolute value of x. The transformation, this 4 is inside. When it's inside, it goes right and left, and it's the opposite of what you think. So this one is going to be right 4. Number 4, there's no number added or subtracted. Instead, we have the function is multiplied by a number. And when it's multiplied by a number, it's either a vertical stretch or shrink. If this is a number that is greater than 1, it is a vertical stretch. Oops. And we say a vertical stretch by a factor of 3. Now, what I didn't do is I forgot to write the parent function, but because this is x cubed, it's the cubic one, x cubed. All right, number 5. This has got 2 things going on, but first let's address the parent function. The parent function is going to be the radical, the square root of x. 2 things happening. Inside moves it right and left, and it's the opposite, so it's going to be right 4. The outside moves it up and down. It's exactly what you think, so it's going to be up 8. Number 6, the parent function on this one is the quadratic one. So we have f of x equals x squared. The transformation, well, inside moves it left and right. It's the opposite of what you think, so it's going to be left 3. And then the negative 6 outside moves it up and down, and it's exactly what you think, so it's going to be down 6. Number 7, the parent function is the absolute value of x. Oops, that's supposed to be a straight line. And the transformation, there's 2 of them. Inside, we've dealt with this negative 4 inside a bunch already. We should know that one. That is right 4 because inside moves it left and right. But this negative outside, this negative turns it upside down. And we call that a reflection. Okay, let's look at the last one, number 8. Parent function is the cubic. The 2 inside changes it left and right. And so it's going to be, whoops, not x. It's going to be right 2 because it's the opposite of what you think. The number outside goes up and down, and it's the same as what you think. So it's going to be down 7. All right, now that we have reviewed the parent functions and transformations, let's take a look at these and see if we can write the equation. Well, all 3 of the first one have the same picture. It's the same shape, and that shape is called a parabola. And when it's a parabola, it is a quadratic equation. And the parent function for that is f of x equals x squared. So now that we know the parent function, we want to try and write this equation. Well, let's think about what that graph looks like. The middle of that graph is going to be right there at 0, 0. So based on where that middle is, we can decide how the graph got shifted. So if I look here at number 1, this graph got shifted down 3. Well, when it's down, the number is outside of the function, and it's exactly what you think. So this is going to be x squared minus 3. Okay, let's compare this to number 2. This one, this center point got moved up 1, 2, 3. So this one goes up 3. So it's the opposite of what we just did on number 2. So this is f of x equals x squared plus 3. Okay, let's see what happens on the third one. This time, the center got moved a little bit. It got moved right 2, but it also got moved up 1. So the right and left is inside of the function, which means we need to put it inside parentheses, and the up is outside. So we're going to have f of x. Now, when it's right and left, it's the opposite of what we think. So we're going to say x minus 2 squared and then plus 1. Okay, let's look at number 4. Number 4 is an absolute value. When we have the absolute value, the equation is f of x equals the absolute value of x. When we graph it, it forms a V. And when it forms a V, the center point is right at 0, 0. So based on where that 0, 0 point is, we can figure out how it got shifted. Over here, it got shifted right 1. And when it's right and left, it's inside of the function, and it's the opposite of what we think. So this is going to be x minus 1 inside. Okay, over here, let's look at this one. 1, 2, 3, 4. It got shifted right 4. So it's going to be exactly like example 4, except instead of a 1, it's going to be a 4. All right, well, on number 6, the origin is, the center point is right there at the same spot. That didn't change. It just got graphed upside down. And when it gets graphed upside down, we call that a reflection. So it's going to be the negative absolute value of x. All right, let's look at these. These are all the cubic equation. The cubic is f of x equals x cubed. And just like all the other parent functions, okay, that center point is right at 0, 0. So if we know how 0, 0 got adjusted, then we know what the transformation is. This one, it went up 3. And when it's up and down, it's outside of the function. So it's going to be x cubed plus 3. Over here, it went down 2. When it's up and down, it's outside of the function. So it's going to be, here, let's write down 2 so we don't forget, f of x equals x cubed minus 2. Okay, this is a little odd, this bad copying on my part, but this right here is supposed to be 0, 0. So on this one, it got moved, and it got moved this way to the right 2. Well, when it's right and left, it's inside of the function, and it's the opposite of what we think. So it's going to be x minus 2 cubed. So when it's down, it's outside like example 8. When it's right and left, it's inside like example 9. Okay, the last part we've done before, but I think it's good to redo. So looking at this parent function, I want to move it and do all the transformations. Before I do that, I'm going to identify these points. Like this first point is -6, -3. This one is -1, -5. And this one over here is 5, 1. Now that I know the points, when I go to move them, it'll be easier. So if I look, this -2 is inside, moves it right and left and the opposite of what I think. So this is going to be right 2. The +3 is outside, so it's going to move it up and down and exactly what I think. So it's going to be up 3. So I'm going to go over to my graph and find the point -6, 3. From there, I'm going to go right 2, and then I'm going to go up 3, and here's my new point. Next one, -1, -5. I'm going to go right 2 and up 3. Here's my new point. Next one, I'm at 5, 1. I'm going to go right 2, up 3. Here's my new point, and there's my graph. Okay, let's try it again. This one, the 3 is inside. That's going to move it right and left and the opposite what you think. So it's going to be left 3. The -4 is outside, so that's up and down and exactly what you think. So that one is going to be down 4. So my original point was -6, -3. And so now I'm going to go left 3 and down 4. All right. Next one is at -1, -5. So I'm going to go left 3 and down 4 And there's my point. Last but not least, I'm going to go left 3 and down 4. And there's my point. Here's the graph. Okay, number 3. Number 3, there's a negative in front of it. When there's a negative in front of it, we talked about that being a reflection. And the reflection does not change the x's, it only changes the y. Everything that was below is now above, and everything that's above is now below. So instead of having -6, -3, we're going to have -6, +3. And instead of having -1, -5, we're going to have negative, I said that wrong. Instead of having -1, -5, we have -1, +5. Instead of having +5, 1, we have +5, -1. And it changes like that. Okay, number 4. On this one, there's not a number added or subtracted. There's a number multiplied. And when it's multiplied, it's either a vertical stretch or a shrink. If the number is greater than 1, it is a vertical stretch. Okay, and we say by a factor of 2, or just by 2. When this happens, we do not change the x's, it's only the y. So in this first point, the x of -6 stays the same, but the y gets doubled. So if I double -3, and I'm doubling it because there's a 2 in front of it, -3 doubled is -6. So my first point is -6, -6. My next point was -1, -5. So the -1 stays the same. We double the 5. It's going to be -10. So we have -1, -10. The last one is 5, 1. The 5 stays the same. I double the 1, so I'm going to have 5, 2. And if you look at my new picture, you can see that this got stretched vertically. It got stretched up and down. All right, the last one we have, there's a number in front of this, and it's multiplied, so it's going to be either a vertical stretch or a vertical shrink. Because this number is between 0 and 1, it's going to be a vertical shrink. And then we say by a factor of 1/2. Now the first point was -6, -3. The -6 stays the same, but I need to take half of the y. So half of -3 is 1.5. So my point will be right here. The next one was -1, -5. The -1 stays the same, but I'm going to take half of the -5, which would be 2.5. The last one is 5, 1. The 5 stays the same, and I'm going to take half of the 1, so it's 1/2. And there's my graph. And compared to the other ones, that definitely got shrunk down.